Thanks very much, Chris. Next up, I'm pleased to welcome Conor Gilmour from Heriot University, who'll be giving us an update on the CHASANS project.
Hello. So my name is Conor Gilmour. I'm here on behalf of Joe Porter, who heads up the CHASANS project from Heriot in Orkney. I've been involved in this for about the last year, helping to do some of the experimental stuff, deploying our bioframes out in the sea to get data. So the aim of this project is to understand how the hard substrates in the North Sea are connected, because it's not entirely obvious. We've heard about artificial reefs and that, but it's not entirely obvious where the actual populations are coming from that seed these reefs or seed these structures and create the epifaunal biofouling that comes on. So we're trying to plug that gap in the literature by going out to as near as we could get to sites and placing buoys. You can see one just there below. That's one of our marker buoys, to try and get an idea of the sort of larvae that are in that area, to see what and find out where they come from and see if we can plug the gaps about how the larvae is dispersed across the North Sea. So it is a large team. I don't actually know all of them because I haven't been involved from the start, but there's geneticists in the National Museum in London, the National Museum in London. The National Oceanography Centre did a lot of work on modelling. There's policy people in the University of Hull. Some of them are here. So it's a big project, and I'll try and give an overview of what's going to happen with it. So like I say, the challenges, this is relevant because when we put structures in the North Sea, we are sort of interfering with how the larval populations are being distributed, because I don't know why that's doing that. Sorry. We're interfering with how the larval populations are being distributed. We're getting these sort of intergenerational seeding steps. So populations can maybe go further than they did in previous, like pre-hard substrate times. They can maybe go further over the course of generations, we just don't know. So that is the purpose of this. And why that's important is this is some of the work that's done by the University of Hull. So they're asking people here from the North Sea, or stakeholders in the North Sea, how they think the sort of marine structures will develop across the North Sea. So you can see it's not entirely surprising that a lot of more renewable energy infrastructure is going to be installed in the North Sea. And that has a surprising effect on the amount of hard substrate area. So we're talking 2,000 plus percentage points of increase at these wind farms just in England. That is quite a lot. So there's a huge amount of hard substrate being added, and that will have influences on the connectivity and larval dispersion across the North Sea. So like I say, we've got some models, computer models, which I'll talk about in a second. We also did experimental data, or the experimental work we did in Orkney was to try and validate these models. Part of it was just to find species, because it's not immediately obvious which species we can get from sites all across the North Sea, and then do the sort of genetic analysis on. And then hopefully we can use the information that we get on the validated models to predict what is actually going to, predict what happens when we add or subtract new substrates in the North Sea. So this is just going over what was done at the National Oceanography Centre. This is the sort of computational model, which is done with some net ocean data. This one here, Scottish Shelf model. And they sort of conducted this particle tracking predictive model here. So it sort of shows what's happening here is that they're injecting these like green points here in the model. They're producing a sort of pathway that they want it to follow, and then they're letting it run for a month, and the orange dots are where larvae end up after a month, given the sort of predictions of the currents and whatever's happening in the water. And you get sort of fairly what you would expect. There's a lot of connectivity around the coast. There's a lot of flow through the sort of Fair Isle Gap here. And there's not a lot happening around the sort of amphidromal point there, around the sort of Tiffany Andrew Huntington platforms. So these white squares are actually the sites where we wanted to put our buoys, our sort of biofouling frames. Couldn't get everywhere for lots and lots of reasons, but we did manage to get 3 out across the North Sea, plus the 2 at the EMEC test sites in Orkney. Thanks to EMEC, because we could sort of stress test our systems there. But there's one there, that's the Moray East Wind Farm. This is on the Little Halibut Bank, and this is the Tiffany Oil platform that I showed you in the first slide. These are the systems that we put out. It's a buoy connected to this biofouling frame. There's just some sort of bar stock that you can attach different substrate tiles. It's about a meter, that just sort of meter square. Tiles are about 125 centimeters squares, half a ton of weight, and you can see here just the sort of the actual difference in depths that we're looking at here. So like we're trying to find a species that so this one is the height of the panel in the water column, and this is the length of the mooring, which is about double the actual depth that we're looking at. But we're trying to find a species that exists everywhere here, and that's why we needed to do this experimental data. This is just suspended in the water column by these 3 trawl floats. That's the point of that, so it's not dragging along the surface. And that was modeled by Dr. Rob Harris using Orcaflex, which was necessary because you'd hopefully put some massive weight down there, and that would but that has problems with how strong everything has to be and costs. And we had to model this quite carefully because the tolerances are small. And so these are actually just pictures of what went out. These are the panels around a meter square. There's some slate, there's some stainless steel, there's some anti-foul coated steel, and also some plastics. We also just put loggers on them as well to try and get some idea of how they're behaving in the water. So we got the sites out. The Orkney sites went out in June 23, and the North Sea sites went out much later. Quite difficult to get that done logistically because it was quite close to infrastructure. That's what they looked like in the water, and surprisingly, despite one of the worst winters in the North Sea anybody can remember, we recovered 1 buoy from each site and most of the stuff that was in Scapa flow. So this is what comes back after, this is about 1.5 years in Scapa flow. And then this is just some sort of, like I say, we only recovered the North Sea sites a month ago, so I haven't really had time to do any sort of processing because I've been away for the last month. But I'll give you an overview of what we're going to expect to happen with the sort of data in the future. So here's just a sort of kind of quick and dirty way to do percentage cover, a sort of random dot generator, and you can color them in with various colors as per species. This is, if ever there was a job for AI, this is it, because it's tedious. But it sort of gives a good idea. It's sort of a good sort of first pass view at what's actually going on. So this is the Scapa flow, this is the Scapa flow site, and this is the Billy Crew site. So this is a West Atlantic site, and this is a sort of sheltered site, and you can see there's a clear difference with what's going on there. This is just a brutal environment, and this is a benign environment. We also went through the work of actually just sort of picking out all of the samples on every single tile. These are species, and these are the rows are tiles. More green is more species. So we're looking for kind of species that occur all over the place. So these are the sort of species we're getting. Lots of Spirobranchus and soft corals out Billy Crew, and then lots of kind of the same things, but also crustaceans and hydroidy material at Scapa flow. And then you can see here substrate basically, it doesn't really seem to matter very much. And then finally, this is one of the tiles that we got back from This is Moray East, and you can see it's absolutely covered in saddle oysters, which is fantastic because we have saddle oysters everywhere now. We have saddle oysters from Tiffany, we have saddle oysters from Little Halibut, we have saddle oysters from Moray East and the Orkney sites. So these will all be packaged off and sent to the Natural History Museum in London, where the genetic interconnectivity will actually be studied, and hopefully we'll have more to talk about after that. Thank you very much.